Good morning and welcome to everybody, those who are present here and those who are online for this third webinar arranged by the Mumbai local chapter of Indian National Academy of Engineering. I would like to thank the Electron Beam Center Technology Development Division Group BARC for hosting this webinar, which is now running in hybrid mode. And during the pandemic years 2019, 20, and 21, most of the webinars were online mode, but with the encouraging support of the earlier committee members and the co-chairs, Professor Grover and Professor Suresh, is in 2022 with the new committee. And I welcome you all, and I thank all the participants who are present here. And this to integrate different communities together, research institutes and also from the industry. So we have been arranging this kind of hybrid mode webinar for last 3-4 months, and this has gone very successfully because in the sense that the participant speaker. And earlier we had some occasion to have these webinars at Homi Bhabha National Institute Mumbai and NITI Mumbai. There many students interacted with the speaker, and today we have another opportunity with our speaker Shri Gupta ji, who will be delivering his talk, and then there will be opportunity to interact with the various users of this electron beam from the industry, from the agriculture. So welcome you all, and I really miss the contribution and the presence of Dr. Archana Sharma, who had to be away because of some personal crisis moment. But fortunately, his colleagues and specifically Mr. Saroj has taken this responsibility to host this program. And I welcome you all on the behalf of Mumbai local chapter. And now I will request the organizers to introduce the speaker, and then we will have this lecture. Thank you.
First of all, I request Dr. Singh to please accept the bouquet as a token of your honor. And also this memento. Now I request Sri Martin Mascarenhas, Head Laser and Plasma Technology Division, BARC, to introduce the speaker, Sri S.K. Gupta. Martin, sir.
It's an honor to introduce BARC, and besides, he's a very good friend of ours at BARC. He joined and has been working as an accelerator professional since then. He has worked on around 7 accelerator projects at BARC in association with TIFR. His illustrious career expands to not only being an accelerator professional, but also he was an officer on special duty of the Department of Atomic Energy, New Delhi, that was responsible for the coordination with all departments and ministries of the Government of India. He was, for a brief time, a project director of Global 6th R&D Center of DAE located at. He was also a member of the project's implementation committee for successfully setting up a 100-ton per day radiation hygienization of municipal dry sludge sewage sludge project at Ahmedabad and Indore under the Smart City program. He has been conferred with a number of awards and has received many Best Paper awards too. I would request Shrikrishna Gupta to kindly deliver his lecture.
Thank you, Dr. Martin. It's a big honor for me to discuss on Indigenous Electron Beam Accelerator for agriculture and industries. I would like to thank local Mumbai chapter of INAE. Professor Kulkarni is online. Dr. R.K. Singh is available here, and other office. Thank you all for providing me this platform. I also would like to thank the Government of India. Thanks to Director BTDG and other senior colleagues present online, as well as invitees from agriculture, academic institutions and industries, and our progressive farmers also sitting here. So good morning to all, and of course online participants through this hybrid mode. So it's a good opportunity for me to share basically this talk which I am going to present. It is a I would say Government of India under this Amrit Call, Azadi Ka Amrit Mahotsav mein, lot of expectations are there, and as our Honorable Prime Minister Sri Narendra Modi on Saturday, he gave a wake-up call to all the scientists that scientists and technologists have to come out of the silo. So on those lines, I'm going to discuss some of the things, and I request my all audiences to see that how this brainstorming session can be utilized for the societal benefits. Our scientists who are putting so much of hard efforts, and whether we are able to bring out technologies from laboratory to land and make our society beneficial, and this will be a social responsibility of all our scientists and technologists. So I will start with this particular talk. I will be referring to gamma irradiation mode as well as electron beam irradiation mode. It is not a competition actually. It is basically we have to see that we should go for advanced technologies. We should have a mentality to accept the superior technology which is now available with the time. For example, I just want to tell that there was a time when Nokia mobile phone, it was so popular. 90% people were having a Nokia mobile, but they were not able to keep the pace with the technology. Windows mobiles, mobile is nowhere. So this is the situation. So this is a wake-up call for all industrialists. We have to ensure and its strength, its mandate, but still facts we will talk about. We will have electron beam machines development chronology, then application of EB in food and agriculture, opportunities for fostering collaborative industries, and then I will conclude. So the motivation, just Saturday, September 10th, 22 at Ahmedabad, Honorable Prime Minister gave a wake-up call and called all scientists and technical community to get out of the silo. This is a very important thing which I thought this should motivate people, because government also have a lot of expectations from the scientists. Prime gave a call, Jai Jawan, Jai Kisan. He has emphasized on the innovation. We have to see that why not to adopt the innovative technologies, innovations has to be put. And for that innovation, it is a joint responsibility of the R&D units plus industries, because industries, we know that industries have some different requirement. So unless they come to R&D scientists and they discuss this, their problems, their expected performance of any machinery or any process or any technology, scientists cannot work on it. So it is a hand-to-hand requirement that we have to have hand-holding of each other and see that how these technologies can be migrated from laboratory to land. So this is one of the motivation. Another motivation, on December 15th, 2021, Government of India again announced a policy decision of arranging 76,000 crore rupees special incentive schemes for semiconductors. So this again, you see what is the motivation, that what is the strength and what the government wants. So these are the things which we should really take an opportunity and see that how the society can be helped. For that, again, there is a call through the scientists and the industries that come on, this is the time we should not miss the boat. So another opportunity, again, motivation from another minister. He announced on recently, February 15, 2022. This was announced by our Minister of State, Dr. Jitendra Singh, Honorable Minister of State, PMO, that Ladakh, for the first time in this season, exported huge quantity of apricot into Dubai. Apple was also to be dispatched to various cities within the country. So everybody wants that our farmers, our growers, our industries should grow. And another thing is that our 5 trillion economy also has to be kept in mind. So all those things comes inclusive efforts. We have to see that how everybody puts their efforts and how the things can be taken forward and our dreams can be fulfilled. So the last motivation point which I would like to discuss, this was again during COVID time, May 16, 2020, a special policy announcement was done to boost the COVID affected economy. And in that one also, atomic energy related announcement was there. And there also government announced that research reactors in PPP mode for producing radioisotopes and medicine. So Bhabha Atomic Center has got a lot of mandates, R&D in field of advanced reactor technology and fuel cycle, radioisotope production in medical and industrial application. These are the main things. Other than that, R&D on food technology and nuclear agriculture, bioscience and technologies. So these are the major things. And the important aspect which I am talking here, the radiation technology and its application for societal benefits. So these are the mandates. And of course, basic research education linkages. So that is again the responsibility of BRC and mandate, that how this we can tie up, we can have good hand-to-hand Indian universities and how the research activities can be taken forward with the help of Indian education systems. So we need a lot of human resource. Indian universities also is very important. So these are the linkages which is really useful, and it is going to take care of the future requirements of the country. So let us talk about radiation processing technology. Very simple. In day-to-day life, we see cosmic rays, the energy coming from sun. That is the major source of radiation. Gamma rays, we see a lot of medicines, X-rays, means we go through the medical treatment where gamma rays emitting from cobalt-60 or cesium-137 or many other source. Then X-rays, of course, everybody knows about it. What is X-rays? Then ultraviolet rays, visible lights, infrared heat waves, microwave, and radiation waves, radio waves. So these are not new to anyone. I hope everybody knows about the source of radiations, and exposing any material to a controlled dose of ionizing radiations to achieve objectives like cross-linking of bonds in the polymers, produce free radicals in the liquids, so that you can get the required benefits. Then eliminate bacteria, eliminate pathogens, insects, killing the cells which are causing malignancy for the human body or any biological cells, and also to improve the characteristics of the devices, particularly semiconductors and other industrial products. So these are the main radiation processing technology about. But here I want to tell everybody, because there is a myth that radiation causes cancer, or radioactive food processed by radiations are harmful to the body. So here the myth has to be made very it is made clear through this platform that irradiation does not and cannot make food radioactive. So one should get the clear-cut idea that by irradiating food or medicines or any product, any industrial product, it cannot become radioactive, because for all such things there are safety guidelines, and those safety guidelines are monitored, and it is controlled by radiation safety officers appointed as a regulator for entire plants. So that is for sure. One should not have any doubt about its any radiation causing any radiation to the food products. So now this is a slide where we can talk about what are the applications, which locations. So starting with the environment, you can have sludge hygienation. A lot of diseases are taking place because of the municipal waste getting discharged into the water bodies. So we can do the sludge hygienation, and we can utilize those hygienized sludge as a organic manure. So that is another benefit. Then we can go for a quarantine effect for radiations. So mangoes, pomegranates, and other variety of fruits, they can be sterilized. Their shelf life can be extended, and they can be transported through alternate source, like for example, you talk about US or European or any other remote continent, where all these things can be exported by only air cargos, and the cost of transportation is very high. But now protocols have been developed, and we ensure that these commodities can go overseas through sea medium, and the extension of this shelf life and delay in farmers. Of course, fresh and fish meats and other products, animal feed, they are again source of good income for the Indian industries. So they also can be now exported using radiation treatment, and we can get a better earning for the society. Of course, talking about the coloration of gems, because again good amount of revenues are being produced in the country. So if we can, means we have been doing it in our EVC and other places, that these diamonds and gems can be colored as per our specific requirement, and standard dose, calculated dose can be given, and we can get the desired color. Of course, medical sterilization we talk about, or cross-linking of polymers. Lot of cable industries are doing cross-linking of PVC and other materials. So the sheath becomes stronger and it becomes fireproof, smoke-free. So these are the industrial applications, and I will talk about agriculture and food things in detail. But lot of things which can be done. Since this talk is particularly targeted for only right now as a agriculture and food, we will discuss how these food products and the agriculture produce can get better yields and better benefit. Of course, I will just talk about the water treatment, that also being taken up in a large scale under Namami Ganga project. Also, we are seeing that accelerators can play a big role, and environment, EB flue gas treatment, you can convert flue gas into fertilizers. That also have a lot of demonstration these characteristics can be improved, switching frequency, their performance can be improved. So in short, this is the slide where you can see how radiation sources can be done, whether it is a gamma or it is electron beam. So that I'm not debate on that, because initially, as I gave the example of Nokia and other window phones, purpose is same. Means both mobiles were able to do the communication, basic thing. But what are the other benefits? So that benefits has to come from the other new advanced technologies. So I will highlight on those new technologies which accelerators can provide. Coming to next, as I said, there are some protocols, WHO, FAO, then IAEA and FSSAI. These are the security agencies who are monitoring, who are regulating the application of radiations for variety of applications and for various commodities. So if you talk about cobalt-60 based gamma irradiators, cesium-137 based, there are certain half-lives, there is a limitations, and energy ranges are given here. And of course, the electron beam also has two modes, electron beam as well as X-rays. So energy is up to 10 MeV maximum is permitted, whereas 5 depending on the local watchdogs. And there are some, depending on the energy, there are some penetrations in the material. So you can go, depending on our requirement, we can use either EB mode or X-ray mode, and so on. So this under the Gazette publication, food products and dose limits are given for radiation processing, and foods, they are classified into 8 classes. And the purpose of radiation and required doses are given in the Gazette. So these things are well notified, and there is absolutely no reason to worry about it. And lot of industrial products, other things are, dose limits are given, and this is given by the Gazette of India published. And all facilities keep a control on these doses, and there is a radiation safety officers appointed at each and every facility. Without that, they are not permitted to. So it is the responsibility, and they are all based on plants. There are plenty of plants, such 31 plants are operational, and 8 new MOUs also signed by DAE, BRIT, and there are 13 gamma plants under construction. So you can see that radiation is now picking up. Now means people are raising to the occasion, and they are saying, yes, this is a beneficial thing, and one should utilize it, because as 40% of our harvested food is getting wasted, and we cannot afford to do it. We cannot afford to have that wastage, because saving the product is equivalent to growing and harvesting the product. So if harvested food can be protected and it can be extended, so it is always better. So you can see that so many plants are coming up. So this is all about the gamma and other safety guidelines. And now I will just give a small brief introduction about the electron accelerators. There are, on the basis of cyclotron or linear accelerator. So we will not go in those details because they are purely technical. Right now, just to have a concept that there can be a DC accelerators where you have a high voltage terminal, a source of electron beam by electron gun is injected, and it is get a repulsion or attraction depending on the electron. So electron beam is there, it is negatively, which positively put charge. So you, by force of repulsion, the accelerator ion beam, electron beam will get accelerated, and you reach to the ground potential. So this is a very simple DC accelerator, And the building blocks of all these accelerator, you have an electron gun, you have that accelerating column, you have the focusing and steering coils, magnetic coils, and you have a scanner. Because normally the electron beam is a point source having certain diameter, 2 millimeter, 3 millimeter. So if it can be scanned like a roster, normally what we see in the TV, there is only electron beam and it is moving so fast that you are not able to scan the, means you cannot scan the dot, but you can see the fill roster. So same thing is applicable here, that electron beam is allowed to move in XYZ direction, XY directions, and it gives a rectangular area where you get a uniform radiation of the object, whatever is put across. So there can be a single cavity resonator accelerator, there can be multi linear accelerators. So all these type of accelerators have the same principle except the mode of acceleration. So we are fortunate that our center at EBC is having all type of accelerators, and all accelerators, our visitors here who are in the physical mode, they will have an opportunity to see all these type of accelerators their own, and they will get benefited. If I talk about the chronology of development at electron accelerators at BRC, we started with 500 kV DC accelerator in 1998, and our Honorable Prime Minister Shri Atal Bihari Vajpayee inaugurated it. Then followed by 10 MeV RF LINAC in 2008. This occasion, we had an honor to get it inaugurated by Honorable another PM Dr. Manmohan Singh. Then 9 MeV RF LINAC came up, followed by 3 MeV DC accelerator. Again, we are lucky that this was inaugurated by Honorable President of India, Pranav Mukherjee, late Pranav Mukherjee, and we RF LINAC in 2016. DC accelerator based wastewater treatment 2018. Again, we had a privilege of getting such machines inaugurated by Honorable Prime Minister Shri Ramnath Kovind ji. And of course, 1 MeV DC accelerators is operational recently during COVID time, and it is performing well. We will be able to see the beam coming out of this accelerator today. And dual energy LINAC for cargo scanner in 2020 on industrial scale by our another unit at ECIL. Then of course during COVID time we have done one electron accelerator simulator also, which is being used for training the personnel. So this is the about chronological of the accelerators. I will just go quickly through the photographs for the benefit of our hybrid participants sitting across their monitors. So you can see the 500 kV surface treatment electron accelerators, then 3 MeV cable and flue gas treatment accelerators, 1 MeV wastewater treatment accelerator. All are located here. Of course, first one is at Brit, about 10 kilometers from here, and Washi. Then 10 MeV 3 kilowatt RF LINAC at EBC. You can see how the product loading on the conveyors are done, control rooms, and there are different components, building blocks of the accelerator. There is the electron gun, there are sputter ion pump, there is a RF LINAC cavity, microwave source, beam diagnostic chambers, and turbomolecular pump and scanning horn. So these are the main building blocks of an accelerator. RF electron LINAC radiography and cargo scanning. These are being deployed at our ports, Indian ports, and at the borders where a lot of movement of the trucks and vehicles, commodities is taking place. So we can efficiently scan the products, cargoes, so that any illegal activities being transportation can be avoided. And country can be made secured for any type of either narcotics or human trafficking or whatever it is, ammunition, all those things can be controlled. So this way, really it is helpful for the nation and the society as a whole. There is a 10 MeV horizontal accelerator, which is again now we are planning to use it for different applications, and this is something which really need of the hour for agriculture. Linux also being developed, and those things are also in a very good shape, and we are now looking forward that all this type of accelerators should be utilized by the Indian industry. There are good amount of technologies transfers are also done, and we see the hope, we see the ray that these things will be commonly available in the Indian market. Now talking about agriculture, that how this mutation of the crops can be done and how these plants can be produced. So there is a presentation in the slide. You can see that gamma and electron beam comparison, that how this how the seeds, this crop plants can be muted for different, to achieve the different benefits like draft variety of the plants. It has been done on many varieties like rice, urad, beans, cluster beans, cowpeas, horse gram. All these crops are muted using electron beam, and how they are beneficial to the farmers and to agriculture industry as a whole. So find that this applications also are extended to chitosan irradiation in 10 MeV at EBC, and you can see that just for the benefit of some of the people who are not really aware of it, this chitosan is actually marine waste. So this marine waste, which is not really useful for the, it doesn't have a sale value, fine value. So it is like a garbage coming out of the marine products. So these things can be processed, and then that is can be, otherwise it is going to be harmful for the environment. A lot of means it will have health hazards and waste problems. So if it can be processed and it can be irradiated, then it becomes a very good organic manure as well as pesticide. So this way you can see that how this marine products can be used, and then the post irradiation with 50 kilogray it is made useful, and you can see the effect of this chitosan with the help of Vasant Sagar Sugar Institute. Delegations are available here today. So we thank you, our participant, that you have taken some time to participate in these things, and we would like to have direct interaction with you so that it will be really useful, and these things can be taken forward for the greater heights. So you can see here plant how it is getting benefited in terms of its germination, proper tailoring of the plant, and regulate photosynthesis. You can see right hand side is using chitosan, and left hand side is a normal chitosan. So you see that how this electron beam irradiated chitosan is helping the plants, and a lot of benefits are given. So it gives us Swachh Bharat, because you are processing the waste, you are processing the marine waste, otherwise it would have been a health hazard. You are making a Swasth Bharat because health is taken care, and Samriddha Bharat. So you are earning, it's a source of earning. It's a gold. You can generate a lot of finances out of this waste. So हमें situations को देखते हुए waste से wealth बनानी है. So this is how these things can really help, and this is societal benefit and responsibility of the scientists of agriculture education as well as technical scientists, that how these things can be served to the society and society can get benefit. Experiments are done on papaya, soybean and mustard at different locations, and we all found that these things are really industry and farmers are greatly benefited by having a better crop for the by using this type of products. These are the photographs of mutants in horse gram. 10 MeV electron beam at 200 gray, and the same thing is being compared with the 300 gray of gamma. You can see the impact and see how these things are getting benefited. All the studies have been done with Indian agriculture universities across the country, and some of the references are given here, that whether we talk about horse gram or we talk about the rice variety ADT 45, that this 10 MeV electron beam has really served, and we are open at BRC group as well as bioscience group. They are open to have agreements and MOUs for developing any other variety of plants which are more popular and for a particular region. So this is a wake-up call for all the agriculture universities as well as the farmers, that whatever problems you have, whatever problems you are facing, that this crop or variety, some changes in the crops to suit their requirement, whether disease resistant or water limited, there is a different type of water available, hardness of the water. So custom made plants can be designed, developed, and it can be tested, and once it can be released through proper procedures set by the government of India and the state government. So this is the opportunity, this is the call given by PM, and we take the opportunity and see that how these things can get benefited. So coming to the next, Moringa variety also we have been testing, and you can see this Moringa, you can see this fruits, Moringa fruits, how thick it is and how tall it is. See, for all you all know that this Moringa is a miracle tree species with abundant nutrients. Every part of the Moringa tree plant, they are useful. It has high protein, it has got very high biological values, leaves, seeds, stem, everything is useful. So this type of things can serve the farmers, and to great extent, talking about electron beam muted electron beam, the fruiting is very high, yield is very high, and even you can harvesting period can be reduced by using this mutation. So depending on the particular agriculture regional requirements, we can modify the crop and get best out of it. So this has been studied by another researchers and published. Now this is all about agriculture, because now time is really running short, so I would not go in detail, but we will definitely go for a discussion with the farmers and agriculture universities available through online or through physical mode here. Now talking about the EB machines for the food preservation, another important aspect. And this is really helpful. So we can classify the doses in three. High throughput applications and very high dose applications at low temperatures, sub-zero temperatures, particularly these marine products or any this meat products and other things which are sterilized, and it is used in the local market as well as abroad. It can be exported overseas. So based on the dose rate, like bulk irradiation of grains and cereals, their ground products, particularly this onion, potato, all they fall in the low dose, high throughput applications. High dose application means bulk or packaging irradiation of spices and frozen and ground meat. So depending on this classification of particular food product, those rates are fixed, and even if something new comes up, our scientists they are capable, they can do the studies, they can put by the approving authorities. So this can be recommended and these doses can be given. So let us not go in more details here. Irradiation of dry fruits, coriander powders, you can see that shelf life of these things can be more than 1 year. Crops are produced and harvesting time is some 6 months to 3 months, 2 months, or depending on the variety. So we can ensure by irradiation, the shelf life can be extended up to 1 year at appropriate temperature. So losses in the storage and due to, we will show some of the products which we have done the irradiation, and you can identify yourself physical here today. In our exhibition, we have put such samples, and you can appreciate that really the food products, harvested food, grains, pulses, and all those things have a really better life. The quality of the food products are really extremely good. So certain food products like potato, mango, rava, litti, thali pit, dried apricot, dried quince, coriander powder, spices, onion powder, black wheat flour, meat, all those things. You can see the range of beam dose, radiation dose, and if they are maintained within this range, it is absolutely safe. And even there is value of any of the product. So that all has been ensured, and it is that mango. These studies have been done for dose uniformity ratio, allowing the facility to be used as a food irradiation on large from food technology divisions. And so far we have been exporting mangoes been done by the electron beam machines also, and the results are very encouraging. And our mangoes, Indian mangoes, whether we talk about Alfonso from Ratnagiri, or we talk about Kesar from Gujarat, or we talk about pan India, these mangoes, best quality mangoes are being irradiated. They are so electron beam, whatever we were discussing about it, there are definitely it has got a weightage and over our conventional cobalt source. So now people always talk about the solutions and costing and other aspects, financial aspect, very important aspects. So there also we have tried to take a case study for 10 MeV 3 kilowatt accelerator and compare with 1 million curie cobalt 60 source. So the material cost, is machine cost, direct expenses, labor cost, all have been considered fairly, and the conclusion is about the per 700 rupees, whereas the cobalt machine average running cost is 6,833 rupees per hour. Here you can see season and off seasons are really going to give a big impact on cobalt 60 machines, because you cannot control the running cost, because source will continuously disintegrate and it will reduce its strength over the period of time. So this is the comparison, and if we compare the throughput of electron beam and gamma, definitely electron beam facilities will be rated top, because I have discussed with many gamma radiators in the country. I had personally visited many places, and I have found that there is a long waiting list of the users. Means there are 6 to 7 days waiting for the users. Every time you see 2-3 trucks are waiting for getting their turn. So because gamma source are having a very slow usage, uh, you can see that about depending on your strength and your product, we can definitely go for faster irradiation. So gamma facilities can give a better throughput of the commodity, and whereas this things gamma has a limitation, and you can have a economically viable option. Of course, you can see the costing of the spices and other onion, potatoes. Here also it is much better. For spices, coriander, onion powder, etc., electron beam can have at 3.7 rupees per kg, whereas cobalt cost is about 6.8 rupees per kg. And same thing for onion, potato, mango, rava, etc. That is rupees 37 paisa per kg, whereas in cobalt 60 case it is about 57 paisa per kg. These are the basic costing of the processing cost. Of course, there and all those things, so that I will not talk about it. But these are the processing cost coming, lending cost for the industry. So you can compare, and just to give final technology, they are having some strengths, some weaknesses. Both technologies are launched by DAE, and of course, like Nokia and any other window mobile phone, this everything has merits and demerits. So here also we have this strength of our EV technologies and what are the weaknesses. Very fair things we are discussing, that indigenous. Technologies have been transferred. We are looking forward that this product will be commercially available as a single button machine. Friendly, user-friendly machines will be available. No radioactive source in handling and management. No source replenishment. High intensity, high efficiency technologies. Dual radiation fields possible. You can have 2 beams, and you can give the get. It does not evoke the public concern because there is no radiation hazard. People can go and walk through the plant when machine is switched off. So, and of course, this is very useful for high dose applications, whereas all the limitations are there in the gamma. And weakness of this facility, if I say, that defined penetration required products packaging consideration, because normally there is in X-ray mode you can have large penetrations, but in EB modes, which is very efficient, but it has got limited air travel distance and travel through the product. So then we have to have the packaging consideration in mind. You cannot have a large size things. So of course, if large size products are there, you can have X-ray mode at the cost of some efficiency, and you can do the irradiation. You can achieve the required performance. So of course, there is a lack of commercial experience, but again, we have to launch into the industry, and of course, this lack of experience is for India, not for the abroad. You can see this type of machines available in the abroad, other countries. China has got 600 EV machines, and it has got only 80 gamma plants. US has more than 500 EV machines and about 30 gamma plants. Worldwide, more than 1500 plants are operational. India is having about 22 machines, and that too only for industrial products, mainly this cable and other PVC cross-linking, various applications. But there are only 22 and 3 machines in our R&D facilities, whatever are available. So there is a very limited number of electron beam machines. So it's a wake-up call again. Thailand, a small country, has 90 electron beam machines. Japan has 300 electron beam machines. South Korea has 60 electron beam machines. So if you see that this is a time we should see that how our electron beam machines can be well accepted by the industries and how it can be launched to the society and society can get benefited. There are, of course, other type of medical accelerators are available, but they are not electron. They are different type. They are proton accelerators, or there are some heavy ions accelerators, variety of applications for medical as well as R&D. Those accelerators are apart from these numbers. So we will not talk about those medical accelerators here. Not the right forum right now. So I will just conclude by saying that actual depth of the based on the papers published in the International Indian Journal of Pure and Applied Physics, that actual depth dose profile of the food product beam is found to be suitable for commercial radiation processing of food products. And so these things should be noted, and this is all based on the certain studies. So my final conclusion here is we have to understand the call given by our leadership. Recently, the call given by Honorable Prime Minister at Ahmedabad, September 10th, scientific and technical committee to get out of the silos. So it is our scientists and agriculture universities and the technical industry for us. We have to see that how we can serve the society, and we move forward, we raise to the occasion, and we can help the society and of course our economy. Need for fostering collaborative research to strengthen the R&D in all. See, it is all hand-to-hand support required from each other, and to make our or with your issues, with your problem initiative, and they cannot innovate the technology. So we need to see that what industry needs and what are the problems faced by the scientists. They cannot foresee the problems. So let us come forward, meet, have good discussions, fruitful discussions, and see that how we can help each other for the mutual benefits. Indigenous and mature technology needs to be deployed for social and social benefits. Indian industries and universities are expected to incubate industry-friendly machines by joining hands with the large R&D centers. So BARC-DAE looks forward for proposals from interested parties, and see that how these things can be taken up. Our industrial units, Electronics Corporation of India Limited, they have already started manufacturing such electron beam machines, and some other industries also have taken the technology, and they are also working to make the good machines for the industries, for the agriculture universities, for the common users, and how that things can be benefited. So now government policies, as I discussed in the motivation part of this one, they are supporting R&D in all the diverse technology field, and it is a time to make joint efforts to make India 3 trillion economy and be global center of research and innovation during next 25 years of Amrit Kal. Thank you very much. I just would like to acknowledge authors, their research work referred in my presentations. These are not all. There are many more authors who have done intensive studies, and they have done a lot of work on it. So thanks to all. And I have just given some sample authors and their photographs. Thanks to Secretariat, Director BRC, colleagues, Dr. K.C. Mittal, Dr. Dr. Archana Sharma, Dr. Nishan Chaudhary, Sri P.C. Saroj, and all other available colleagues from EVC, Food Technology Division, Nuclear Agriculture and Biotechnology Division, BRC, for very informative discussions and support. INAE authorities at headquarters as well as Mumbai chapters for providing platform for this presentation, management, faculty of Vasantdada Sugar Institute for active research work. My thanks are also to Samir authorities for providing their logistics infrastructure, and thanks to all who are directly or indirectly supported this endeavor. Thank you very much. Jai Hind.
Now I invite Dr. S.B. Kulkarni, Professor IIT Bombay, for giving the vote of thanks as the part of the INAE chapter. Thank you. We have to connect.
So am I audible?
Yeah.
Yes, sir. Yes.
Part of this, expert lecture on online mode. So I thoroughly enjoyed, not working in this area. It was quite, useful to know the, various applications of radioactive technology. So now I have a pleasant duty to give vote of thanks. So first of all, I would like to, thank the speaker, Shri S.K. Gupta ji, for giving a nice talk, and he explained, first he started with, explaining mandates of BARC, and then he highlighted one of them being the radioactive technologies and its applications for societal benefits. And he commented on some of the myths of the perceived risk of this technology and assured all of us that, it is absolutely safe and quite useful for society. Then he also talked about, sources which are permitted and their levels. Then he also said that there are some gamma source-based processing plants. 13 of them are under, execution, and these plants would help food wastage, stoppage during storage. He also narrated various other applications like surface treatment, water treatment, cargo scanning, waste to wealth possibilities, food preservation, and even in export of mangoes to abroad. He also compared nicely the two technologies, that is electron beam and gamma technologies. And he highlighted that the running cost of EB technology is much lower, and hence it is advantageous for societal applications. So he finally, while concluding, he highlighted and stressed the need for industry institute collaborations along with and tie up with BRC for promoting applications of radioactive technology for societal benefits. So thank you, Shri Gupta ji, very much for agreeing to give a talk and enlightening the audience about this technology. I would also like to thank Kharghar division of BRC for arranging this talk and nicely hosting this all arrangements. So I would like to sincerely thank the Kharghar division. Finally, I would like to thank INAE headquarters for making this online arrangement of this webinar. As usual, they have been very helpful for conducting webinars during the pandemic in completely online mode, and now post-pandemic in hybrid mode. So thank you, INAE headquarters, for this. With this vote of thanks, I hand over the mic to organizing team. Thank you.
Thank you, sir. Thank you very much, sir.
India attained independence on August 15, 1947, after a prolonged struggle for self-rule. Much has been accomplished in the long march since her rebirth. the country having risen to become one of the largest economies of the world today. Science and technology have played a pivotal role behind every facet of growth and transformation of the nation over the last 75 years, catalyzed by R&D efforts of many organizations which have been established over the decades. Department of Atomic Energy, or DAE, is one of the prominent departments which has made significant contributions. The Atomic Energy Commission was constituted in 1948, soon after independence, and the DAE was established in 1954. Thus began India's journey in harnessing atomic energy for peaceful purposes under the far-sighted leadership of Dr. Homi Jahangir Bhabha, the great scientist and visionary. Elected president of the first International Conference on Peaceful Uses of Atomic Energy at Geneva in 1955, Dr. Bhabha played an important role in creating awareness and fast-tracking the use of atomic energy for peaceful purposes all over the world.
The immense concentration of atomic energy has made possible other developments whose immediate results have been less happy and which have placed a pall of fear over the peoples of the world. A widespread atomic power industry in the world will necessitate an international society in which the major states have agreed to maintain peace.
Dr. Vikram Sarabhai, who took over the reins of DAE after Dr. Bhabha, was an able and dynamic successor. He continued to carry forward and expand the atomic energy programs of the nation to greater heights. Activities in India started in earnest with the setting up of Apsara, the first research reactor of Asia at the Atomic Energy Establishment, Trombay, which is now known as the Bhabha Atomic Research Center, or BARC. A second 40 megawatt research reactor, Cyrus, was commissioned in 1960, followed by a 100 megawatt research reactor, Dhruva, in 1983, and a recently built Apsara U reactor in 2018. Radioisotopes produced in these research reactors play a key role in the development of applications related to radiation technology, such as in healthcare, agriculture, food preservation, and several other societal programs of DAE. Associated activities such as uranium mining, refining, fuel fabrication, fuel reprocessing and waste management were commenced in parallel at BARC and other locations for sustaining the research reactor and power reactor programs. DAE also embarked on R&D programs in numerous disciplines carried out primarily at BARC Mumbai, which is the mother institute of DAE. This large integrated center supports research activities in multiple domains, such as physics, chemistry, biology, material science, electronics, etc. Nuclear power generation in the country commenced with the setting up of 2 power reactors at Tarapur, Maharashtra in 1969. Nuclear Power Corporation of India Limited has the comprehensive capability to design, construct, commission and operate nuclear power plants. 22 nuclear power plants are currently operational in India. A state-of-the-art, fully indigenous 700 megawatt electric reactor at Kakrapar, Gujarat has recently been connected to power grid. It incorporates enhanced safety features typical of Generation 3+ reactors. The department comprises of several institutions which harness the power of atom and contribute to nation building. Atomics Minerals Division was constituted in 1949 to prospect and mine for uranium in the country. Nuclear Fuel Complex was set up in 1971 for manufacturing fuel for nuclear power plants. It is the largest integrated fuel manufacturing facility at a single location anywhere in the world, with a capacity of 1,500 tons per year. Electronics Corporation of India Limited was established in 1967 to meet the needs for design and manufacture of highly complex and reliable instrumentation and control systems for nuclear reactors. Heavy Water Board came into existence in 1969 for the manufacture of heavy water required in pressurized heavy water reactors. Manuguru Heavy Water Plant is today the largest heavy water manufacturing plant in the world. Indira Gandhi Center for Atomic Research was created in 1971 for research in fast breeder reactors. Raja Ramanna Center for Advanced Technology was born in 1984 for carrying out cutting-edge R&D in lasers and accelerators. Amongst the numerous societal applications, diagnosis and treatment of cancer is one of the most important wings of DAE operations. Tata Memorial Center, under the aegis of DAE, is a pioneer in cancer research and treatment in the country. About 500,000 patients, including thousands from outside the country, receive treatment every year at an economical cost. More than 240 hospitals across the country have been linked into a National Cancer Grid, or NCG, to share knowledge and resources for uniform and better treatment outcomes. One of the recent noteworthy contributions of DAE in cancer treatment is an eye plaque using radioactive ruthenium for treatment of ocular cancer. DAE formulates radiopharmaceuticals, coordinates clinical trials, creates harmonized protocols, and provides imaging services. Millions of procedures are carried out at DAE centers every year. DAE has an extensive program on mutation breeding for developing improved seeds for various crop varieties. 49 Trombe crop varieties, including groundnut, rice, mustard and pulses with improved characteristics like higher yield, early maturity, improved disease resistance, drought tolerance, etc., have been developed and are being cultivated extensively in the country. DAE has also developed irradiation technology for preservation of fruits, vegetables, pulses, spices, seafood, etc., which reduces wastage, thereby improving the viability, profitability, and availability of these products. Food preservation is also served by the liquid nitrogen-based reefer system developed by DAE for refrigerated transport of vegetables, fruits, seafood, etc. Technologies for smart cities, such as radiation-based sludge hygienization and sewage treatment, are also finding uses in large urban centers as eco-friendly and sustainable methods of urban waste treatment. The hygienized sludge, fortified with nutrients, makes extremely good manure and is marketed under the brand name BioGold. DAE is an active participant in several international mega science programs such as CERN, FAIR, ITER, LIGO, SKA, etc. A massive cryostat, which is the largest terrestrial vessel in the world, has been built and delivered to ITER in the recent past. DAE is a proactive partner of International Atomic Energy Agency in the area of research and training related to nuclear science and technology across the globe. India has also entered into civil nuclear cooperation agreements and regional cooperation agreements with several countries, with the objective of developing mutually beneficial scientific and technical cooperation for the peaceful uses of nuclear energy. Some noteworthy initiatives in this direction include exporting radioisotopes to partnering countries, providing indigenous radiotherapy equipment, Babatron, to partnering countries, bridging the global gaps in cancer care by launching the NCG Vishwam Cancer Care Connect, a linkage for sharing information, knowledge and expertise. Creating a dedicated center known as the Global Center for Nuclear Energy Partnership to promote collaborative research and training programs. With eyes firmly fixed on the future of the nation and indeed the entire humanity, DAE continues to strive towards extending the benefits of its expertise and knowledge in the true spirit of